Let us have the degree and order of the differential equation. So for the degree, that is the highest exponent of the order, and then for the order, that is the highest derivative appearing in the differential equation. So just take note that dy over dx, that is also equal to your y prime, that is the first derivative, and for your d squared y over dx squared, that is also equal to double prime y, that is the second derivative, and for your d cube y over dx cube, that is also equal to your triple prime y, so that is also equal to third, that is the third derivative, and so on. Okay, so for example, this one, um, the order for number 1 is 1, since dy over dx is raised to 1. And then the degree for dy over dx, since it determines the highest ordered term, so that is also equal to 1. So for this one, the highest order for differential equation here is obviously this one. So that is 3. And then for your degree, of course, that determines the highest order, which is in this term. This is the first term. So that is 2. Okay, next. How about this one? Xy prime plus y. So the highest order there is this one. So that is also equal to dy over dx. So that is 1 also. And that is also raised to 1. So the degree is 1. Okay, so for this one, number 4, of course, this one, y double prime, so that is 2. The highest order there is 2, and the degree there is 1. That is considered as raised to 1. Okay, so for this one, number 5, it is still 1. And for the degree, that is equal to 1 also. So for number 6, your highest order there is here, that is 2. And for your degree for the highest order, that is also equal to 2. For this one, the partial derivative of zy and this one, that is considered as raised to 1 also. That is 1. Okay, so for this one, it's the same. That is the highest order, which is 2. And it is raised to 1. That is the highest degree. Okay, so let us move on to elimination of arbitrary constant. So just take note that the number of arbitrary constant to be eliminated in the differential equation determines the number of times in getting the derivative. So for example, this one, number 1, eliminate the arbitrary constant c of the equation x cubed minus 3x squared y is equal to c. So your arbitrary constant there is only 1, which is c. So we're going to get the derivative for that only once. So I just rewrite that one. X cubed minus 3x squared y is equal to c. Okay, so in getting the derivative for this one, let us just simplify this, since that is a product rule for your derivative. Let us bring out negative 3. Okay, so that is x squared y. Okay, since that is in product rule, that is u dv plus v du. So that is supposed to be negative 3 times, that is x squared dy plus y multiplied by the derivative of x squared, which is 2x raised to 1. So that is in dx. Okay, so simplifying this further, it will become negative 3x squared dy minus 6. Distributing negative 3 there, that is 6xy dx. Okay, so rewriting your original equation, let us just simplify that. So it will become this one. So what is the derivative for x cubed? That is 3x3 minus 1, so that is 2. Okay, so for this one, derivative for negative 3x squared y is this, negative 3x squared dy minus 6xy dx is equal to, of course, that is already 0 since the derivative of a constant is 0. But we can just uh, um, we can just combine this one since 3x squared is in terms of dx also. So let us bring out dx, so that will become 3x squared minus 6xy, so that is in dx, minus 3x squared dy. That is our final answer. Or if you want it in terms of dy over dx, let us just divide the whole equation by dx. So that is 3x squared minus 6xy minus 3x squared dy over dx is equal to 0. Or that is written also in terms of y prime, no, yx squared minus 6xy minus 3x squared, that is y prime, is equal to 0. So that is minus. That is our final answer. Okay, next. Number 2, eliminate the arbitrary constant c1 and c2 of the equation y is equal to 24x cubed minus 3 halves x raised to 4 plus c1x plus c2. Since we have here we have here two arbitrary constant, we have to get the derivative twice. Okay, so getting the first derivative for that, that is y is equal to 24 times 3, that is 72. That is x raised to 3 minus 1, that is already 2, minus 3/4 multiplied by 4. So that is equal to 3, or that is 12 divided by 2. X raised to 4 minus 1, that is 3, plus C1 plus 0. Okay. So that is the first derivative. Getting the second derivative for that, that is 72 times 2. That is 144. That is x. Since that is 2 raised to 2 minus 1. Okay, so that is minus. That is already 6 times 3. X raised to 2 plus 0. Okay, so the arbitrary constants are all eliminated. So simplifying this further, it will give us y double prime is equal to negative 144 my x minus 18x squared. That is our final answer. Okay, so for number 3, eliminate the arbitrary constant c1 and c2 of the equation. c1e raised to negative 2x plus c2e raised to 3x. Since it has a variable, the mathematical constant Euler number, which is e, let us use by elimination method, no? So since that is it includes two arbitrary constant, let us get the derivative twice. Okay, so just recall, for your e raised to x dx, that is also equal to ex, that is the derivative of that. Okay, so for this one also, e raised to ax, that is carried the coefficient there, e raised to ax, that is the derivative for that. Okay, so let us just copy the first, c1 e raised to negative 2x plus c2 e raised to 3x. That is our first equation. Let that be our equation 1. Okay, getting the derivative once, that is y prime is equal to negative 2c1 e raised to negative 2x plus 3c2 e raised to 3x. That will be our equation number 2. Okay, let us get the second derivative for that. That will become positive for all. That is c1 e raised to negative 2x plus 3 times 3, that is 9. c2 e raised to 3x, that will be our third equation. So to be able to eliminate the constants, let us have the first equation to the second equation and the second equation to the third, or the first equation to the second or first to the third, or this one, the third to the second and the third to equation 1, for as long as they have a common equation. Okay, so getting this one, let us just first get this. Okay, so at equation 1, let us copy that. Y is equal to C1 e raised to negative 2x plus C2 e raised to 3x. And then at equation 2, that is Y prime is equal to negative 2c1 e raised to negative 2x plus 3c2 e raised to 3x. Okay, to be able to eliminate c1, we are going to multiply equation 1 by 2, so that it will become 2y is equal to 2c1 e raised to negative 2x plus 2c2 e raised to 3x. And then let us just add the second equation, which is equation 2, that is y prime is equal to negative 2c1 e raised to negative 2x plus 3c2 e raised to 3x. So if you notice, we can already cancel this one since they have different sign. Okay, so adding that, it will give us 2y plus y prime is equal to, that is 2 plus 3, since they have the same variables. So 3 plus 2, that is 5. 5c2 e raised to 3x. Okay, let us just rewrite this one in terms of c2. So that is c2 is equal to 2y plus y prime divided by 5 e raised to 3x. That is your equation number 4. Okay, let us continue. Let us just get the equation. At equation 2, that is y prime is equal to negative 2c1 e raised to negative 2x plus 3c2 e raised to 3x. And then at equation 3, since 2 is their common equation, that is y double prime is equal to 4 c1 e raised to negative 2x plus 9 c2 e raised to 3x. Okay, so in here we have to multiply equation 2 by positive 2, so that c1 there will be cancelled, and what leaves us there is the c2. Okay, so multiplying equation 2 to 2 by 2, that is 2y prime is equal to negative 4c1 e raised to negative 2x plus 6c2 e raised to 3x. Okay, so copying equation 3, that is y double prime is equal to 4 c1 e raised to negative 2x plus 9c2 e raised to 3x. Okay, so adding that, this one will be cancelled already. Okay, so that is 2y prime plus y double prime is equal to 9 plus 6, that is 15 c2 e raised to 3x. That is our equation number 5. Okay, so substituting equation 4 to equation number 5, let us just substitute the value of c2 there. That is 2y prime plus y double prime is equal to 15, and your c2 there is 2y plus y prime over 5 e raised to 3x. That is multiplied to e raised to 3x. And here we can cancel e raised to 3x. Okay, so if we're going to simplify that further, so if you notice, there are no arbitrary constants anymore. So our answer is correct. So 2y prime plus y double prime is equal to, so that this one, let us simplify this. 15 divided by 5, that is 3. Okay, so 3 times 2, that is 6y plus 3y prime. Okay, so we have here the same variable, so it will combine. So that is 2 y double prime, 2y prime minus 3y. Let us just get that at the other side. That will become negative 3y prime. So 3y prime minus 2y prime. Let us just carry the negative sign, negative y prime, and let us transfer this 6y at the other side also. That will become negative 6y is equal to 0. That is our final answer. So that is our discussion for the elimination of arbitrary constants.